Assalamu alaikum wa rahmatullahi wa barakatuh. Hi friends, welcome back to the Ambition of Youth. In this video, we are gonna speaking about home automation with ESP8266. First of all, the ESP8266 can only be powered by 3.3 volt. So we have a voltage regulator to regulate the voltage from 5 volt to 3.3 volt. But how can we get 5 volt to regulate? You can use a battery, but this is not effective and you have to change the battery continuously. We'll put this board in our home panel to control the high voltage loads. So what about rectifying the main voltage to 5 volt DC? I have used a high-link power supply to rectify the voltage from 220 volt AC to 5 volt DC. Here is the schematic of the power supply. And I have made an indication of rectifier output by this resistor and LED. According to pin configuration of the ESP8266, we have two push buttons, one at the GPIO 0 to can flash the code, which we have set as pull-up pin, and the other at the reset pin, which we have also set as pull-up pin. These pins can't be used because they are reserved by the chip. We can use GPIO 4, 5, 12, 13, and 14 as input or output. We will use them as output to control the relays. But as you can see, we have 7 channels or 7 relays, and we have used only 5 GPIOs. So I'll use TX pin and GPIO 15 as output to can control the last 2 relays. But how can we program the chip? I have put a 4 male pin header to can program the chip with USB to TTL converter. As I mentioned, I've used 7 relays, and as you know, the relay coils withdraw large amount of current compared to the chip current. So we can't control the relays directly. So I use Darlington transistors, which are embedded in ULN2003 IC to control the coils of relays. And the IC have freewheeling diodes to free the reversed current came from relay coils to protect our control circuit. As you can see, we have a resistor and LED connected in parallel with the coil supply to indicate the coil status, and wired the COM normally open and normally closed pins to a 3-pin screw terminal. This is the PCB layout. I put components on the top and bottom of the board to can get a compact size. And this the 3D view. These are the relays and screw terminals labeled COM, normally open and normally closed. And this is the power supply with the varistor and safety capacitor according to schematic of the power supply. And we have a 2-pin screw terminal, which is the power of the power supply, line and neutral of the power supply, and we have 2 push buttons, reset and flash, to can flash the code which we receive by these 4 male pin header. And at the bottom we have the mini chip at the bottom and Darlington transistors and the voltage regulator and some resistors to limit the current of SMD LEDs, and some capacitors to smooth the voltage. And this is the SMD fuse to protect our power supply from overcurrent.